Hi, and welcome to Meetings in Math. You are here for a special section on slopes of lines, in particular parallel and perpendicular lines. Our essential question is, what would the slope of parallel and perpendicular lines look like and why? And it'll be interesting to see what you think before we actually get to the answers. Today you'll need your Jaguar dots on 4.2e. A pencil, pen, a highlighter might be a little bit useful today, along with a calculator, and your determination and some perseverance, because a growth mindset always helps us learn just a little bit better. So let's get started. So right here we have an example of parallel lines and perpendicular lines. Parallel lines, if you recall, never will intersect, and perpendicular lines do intersect, but specifically they intersect at 90 degrees. So let's go ahead and put a little box in there to remind ourselves that they're intersecting at 90 degrees. So let's look first at some ideas that we know about slope. Slope gives us information about their direction and their rate, or how fast, or their steepness. And so what I'd like you to do is I would like you to predict what you think about parallel lines and how you would talk about their direction in relationship to slope, and their parallel lines and their rate in relationship to slope. I'd like you to predict that first before we actually get there, along with perpendicular lines and the direction and their rate. So go ahead and pause this and think about that and then come on back. Now that you've taken a guess, parallel lines have to go in the same direction. They also have to go at the same rate. So everything about parallel lines has to be the same. I just scooched it over a little bit. So our rates have to be the same. Everything about the parallel line slope has to be exactly the same. I just took my line, which was here, and I scooched it over just a little bit. And what we scooched over was our y-intercept, which was there, and we scooched it down to there. We did a transformation that just moved it from one place down to another. And when we get into transformation of graphs later on, when we're older, you'll see how nicely that works. Perpendicular lines is a little bit different. You can see immediately that they're not going in the same direction, okay? They have to intersect somehow. In fact, they look like they're going in opposite directions. One is positive and one is negative. And their rate is looking kind of funny too. This one looks like it's going up really, really fast. I'm not exactly sure if I'd want to climb that. Where this one looks like a much more gentler slope. Does that make sense when we're talking about here? This looks like a very fast slope, where this looks like a much gentler slope. So even our fastness, our steepness has changed quite a bit. And so the steepness has changed. A little bit gentler slope. So what does this mean for us? Well, what this means is we have totally different slopes. So what are they? I call them opposite reciprocals. So this part right here means that one needs to be positive and one needs to be negative. And this part right here means that they're reciprocals, which means if you have m, the other one's going to be 1 over m. So what does that mean once we put it all together into one great big idea? That means that your original slope, you're going to do the opposite of it and the reciprocal. That's the easiest way to remember it. There's another thing that we talk about, and we say the product is -1. That's like the real mathy, you want to sound really smart, like, oh my gosh, I have all these math smarts. That's what you would say. The product of the slopes is -1. The perpendicular lines have a product of slopes that's -1. That's what you would say. But for practical senses, this is what we do. So let's just look at this. I have a line right here. I have a line with these slopes. The parallel one, what's the new slope? Well, the new slope is exactly the same. Here's the line. What's the parallel line? It's exactly the same. Your turn. Pause and come back. Perfect. That's it. Perpendicular lines is a little more different. If this is positive, it's now going to be negative. If it's 2/3, then we're now going to flip it over and it's going to become 3/2. Do this one. Pause. Perfect. It's negative, now it's positive. 7/10 becomes 10/7. This one, you're going to get probably a little confused. Remember, this is 5/1. So this is going to be positive 1/5. All right, so is the line that passes through the points -3, -2, and 2, 3 perpendicular to the line that passes through the points -3, 3, and 2, -2? So what we're going to do is we're just going to go find the slopes of the two of those, and then we're going to compare them. Okay, so we're going to let the first one be this purpley color, and the second one be this green color, and you are going to find the slope of this one and the slope of that one. You're going to pause it, go find the slopes, and then come on back and make sure we have the right slopes before we go ahead and compare them. So pause it now and then come on back. All right, so this is right here saying the slope of line L is 1 and the slope of line M is -1. So if I look at these, are they opposite reciprocals? Sometimes it's hard to tell when they're both whole numbers like that. But one of the things that we can do is we can go back to that real math explanations, and we can take the product of the slope of line L and the slope of line M. So that would be 1 times -1 equals -1. So yes, the lines are perpendicular because their product of their slopes is -1. So sometimes those real mathy things come in handy because sometimes it's hard to tell just by looking at it where those opposite reciprocals. So that is it for today. We were looking at parallel lines and perpendicular lines and their slopes. We have a really nice way to look at it right here. Parallel lines have the same slopes. Perpendicular lines have opposite reciprocals. And if you can remember that, you've got it. Thank you so much for showing up today, and I can't wait to see you in our next lesson. And remember, be kind to each other because we can all use some extra kindness in our lives. Bye for now.